Yeah, welcome once again to 437 video number 5. We have another example on the board where we want to combine step functions to give a single function. We have 4 things to add. The very first one, because of minus n, when it is switched, it goes to the left, no more to the right now. For this one, 15 minus n, set it to 0, n equals 15. So at 15, I'm going to have 3, 3, 3, 3, 3. The add is going to be 3, 14, 13, 12. That trend will continue this way. No. Yeah, and there are 16. I'm going to have 0, 17, 0, 18, 0, and that trend continues that way. So the next one, that's minus 4u of 8 minus n. 8 minus n, set it to 0. We have n equals 8. That means switching will take place at 8. And then I'm going to have minus 4, minus 4, minus 4, minus 4, minus 4, minus 4. This will be 7, 6, 5. That trend will continue like that. Then at 9, I'm going to have 0. At 10, I'm going to have 0. That trend will continue like that. The third one is u of minus n. Switching will take place at where? At 0. Now you place your 0. I can't place my 0 here. If I place my 0, I'm saying 0 is greater than 6. Impossible. So I place it here. Place it here. And then I'm going to have 2, minus 1, minus 2, 2, 2. That trend continue this way. At 1, 2, 3, 0, 0, that trend continue that way. And then for the last one, that is the axis here is n, the axis here is n, the axis here is n. Now, for this one, minus 3 minus n equals 0, n will be equal to minus 3. So it's at minus 3 that action will start here. That's going to be minus 1 is the height. That trend continue this way. Minus 1, minus 1, minus 1. And this is location minus 3, minus 4, minus 5. At minus 2 is going to be 0. At minus 1 is going to be 0. That trend continues that way. Let's now combine them. Let's combine them together. N. Now, let's start from this end. At 16, 17, 18, 0, 0, 0. That trend continues like that. At 15, I'm going to have 3, 14, 13, 12, 12, 14, 13, 12, up to where? Up to 9. Because switching is taking place here at 8. Up to 9, I'm going to have that 3. But at 8 now, it's going to be 3 minus 4. That will give me minus 1. Minus 1. That's at 8. That trend will continue up to 1. Minus 1. This is at 7. Up to minus, up to plus 1. I'll continue up to plus 1. Where I'm still going to have minus 1. Because another action is taking place here, so that must stop at 1. So at 0 now, plus 3 minus 4, that's minus 1, plus 2, that will give me plus 1. So at 0, I'm going to have plus 1 at 0. At minus 1, I'm going to have 1, minus 2, 1. That will stop at minus 2. By the time I'm introducing I've combined 3 Abby. was having 3 minus 4 minus 4 plus 2. That will give me plus 1. By the time I get to minus 3, this guy is bringing 3, minus 4 giving me minus 1, plus 2 giving me plus 1, then minus 1 giving me 0. So at minus 3, I'm going to have 0, minus 4, I'm going to have 0, and that trend will continue that way. That is that signal. Now, let's talk about impulse signal. So impulse signal, we talk of delta L, just like delta T. Delta L is a 1 at 0. This is L. This is the only signal that is the same, both continuous time signal of it and discrete time signal. It's the same appearance. So if I give you delta n minus 7, that means what? N minus 7 equals 0. It will be at 7. That one will be at 7. If I give you 2 delta n plus 3, that means n plus 3 equals 0. That will be at minus 3. That's minus 3, and the height is going to be 2. So this is an impulse function. Now, let's introduce what we call impulse response. Impulse response. Impulse response. When we have a system, this is a system. If we send in delta T or delta N, the output is going to be HT or HN. H is known as impulse response. Impulse response. It doesn't mean that the two of them will go in. No. I'm telling you, if it's continuous time signal system, delta T will come in, HT will come out. If it's a discrete time system, delta N will go in, HN will come out. So impulse response is defined as the output of a system whenever the input is an impulse function. So it is the output of a system when the input is an impulse function. An impulse function. So impulse response is an important characteristic of a system. So in fact, when we draw the system, we can write the impulse response inside. Now, if we are giving another input and we want to find the output, we simply say that once we know it is impulse response, we can say, so given f of t as input, find g of t, the output. Given, if we are given the impulse response, then the output g of t will just be equal to f of t asterisk h of t. This symbol means convolution. Convolution. Am I getting that spelling? Convolution. Another symbol for it possibly is this. That means once you know the impulse response of a system, you can predict the output of the system to any other input, making use of the impulse response. This is for which type of system? For LTI LTI system. It is only LTI system that this is possible for. So that is the symbol of convolution. If it is, it can be discrete time system too. This will be G of n, this will be f of n, and this will be h of n. We say that G of n equals f of n asterisk h of n. So this is for continuous time system, this is for discrete time system. So let us stop here. We are going to introduce convolution. But before we stop, know that the impulse signal is very important. You use the impulse to find the impulse response. Take that system, supply an input of impulse signal into it. Whatever output that comes out at that time is referred to as impulse response. So once you know the impulse response, given any other input f, you can find the output of this input by simply finding the convolution of f of t and h of t. So in the next video, we are going to introduce convolution. Thank you very much.